3.3 Applications of Nuclear Energy. Let's begin. Mutant butterfly. Radiation is dangerous. Large dosage of radiation may kill all forms of life instantly by high energy. Ionizing radiation may also attack living cells, ionize their molecules, and produce mutation of body cell, which may result in cancer or abnormal body parts. 1. Nuclear power. Nuclear fission or fusion produce huge amounts of nuclear energy. If uncontrolled, fission or fusion may result in explosion. On the other hand, controlled fission or fusion produce stable nuclear power, which can be an energy source to generate electricity. A. Controlled nuclear fission. All nuclear power plants in the world make use of controlled fission. 1. Generating electricity by nuclear power. In a nuclear power plant, there are usually more than one nuclear reactor. There are different types and designs of fission reactors. Many of them uses uranium-235 as nuclear fuel to produce electricity. The one at Daya Bay uses uranium-235 as nuclear fuel as well, and chain reaction of uranium-235 as mentioned on page 89. To produce nuclear energy in the form of heat, which may produce steam to drive a turbine to produce electricity. Such fission is controllable as the number of neutrons in the reactor core can be controlled carefully. Although nuclear fusion may produce even more energy than fission, it occurs at extremely high temperature and pressure, and it is more difficult to control. No practical large-scale nuclear fusion reactor is now available. Example 7. Daya Bay Nuclear Station. In Part B, you can see that the efficiency of a nuclear power plant is about 33%. In fact, a conventional power plant using fossil fuels such as coal or natural gas has an even lower efficiency of 25% only. In Part C, you can see that such a 900 megawatt reactor turns only 0.237 kilogram into energy per hour. A small mass, right? Read the solution carefully. Exam link 2. Nuclear energy. In Part A1, it is given a typical nuclear reaction in a fission reactor using uranium-235. In Part A2, you are asked to explain chain reaction. In Part B, you are asked to calculate the mass change and corresponding energy change in a nuclear fusion reaction. For A1, the conditions for chain reaction was mentioned. For B2, you should first of all calculate the number of reactions in order to find the total energy released. 2. Nuclear waste. Nuclear power stations produce a lot of nuclear waste, as the fission products are usually radioactive, and they usually have long half-lives. Their activities may remain high for hundreds to thousands of years, or even more. Depending on their activity, they are stored differently. Low-level waste is buried near the surface. Intermediate-level waste is buried under a few meters of clay. High-level waste is buried several hundred meters under the ground. They have to be stored there until their radioactivity reduces to a safety level. Many products and byproducts of nuclear fission are radioactive. Leakage of radioactive substances will result in health and environmental issues. The table below lists the effects of some common fission products, and you can see they mostly cause cancer, while iodine attacks the thyroid glands, and strontium may cause leukemia. Nevertheless, The potential hazards of an operating nuclear power plant should never be underestimated. Four, benefits and disadvantages. I suppose you have gone through a critical discussion about the pros and cons of using nuclear power plant in your liberal study lessons. Frankly speaking, nuclear power can be a solution to energy crisis if all nuclear accidents could be avoided, which is unfortunately not the case. Scientists believe that the probability of a nuclear accident is very small, and yet there have been a few occurrences already, including that at Fukushima and Chernobyl. Both are catastrophic, which cause huge loss of the government and the community, not to mention the health and environmental issues they brought about. For details, please take a look of the information about the nuclear accidents on that page. B. Controlled nuclear fusion. Compared with nuclear fission, nuclear fusion appears to be a better solution to energy crisis. As the fuel, which is hydrogen 2, is plentiful, and fusion products are not radioactive. Nevertheless, practical large-scale nuclear fusion reactor is still under research. A few models, such as the JET model at UK, can start nuclear fusion but fail to maintain a stable operation. Do check point 3 below.